All right, today we've got question 2017, number 6. I think this is a fantastic question. It hits on so many different easy calculus concepts to touch. It'd be really neat to see something like this on our 2-question exam. So they give us, let's be really careful, they give us a lot of information. They give us G, G prime, H, and F. So really be careful at what function they're talking about. So part A. Find the slope of the tangent line. So slope being keyword, I want to take somebody's derivative, it's not a guess, of f. So they want me to find f prime at x equals pi. So again, just a nice simple derivative. Read f out loud to yourself. This is the cosine of 2x, so that's chain. And here's a derivative of e rule. So hopefully you said f prime of x equals chain. So the derivative of cosine would be negative sine, keep the inside, times the derivative of the inside. So I've got negative 2 sine of 2x, plus e's are simple, you leave them alone, and then you multiply by the derivative of the exponent, so times cosine of x. And then all we have to do is plug in pi correctly. Now, the best part about the AP exam, you do not have to clean it up. So if you're going to, you need to make sure you clean it up correctly. So I want to be very clear. What I write down, and we have not stressed this enough because obviously we haven't been in class, is full credit. I want you to box this in. This is full credit. Now, if you want to evaluate it further, that's up to you. And if you make a mistake, that's on you. But this is full credit. As long as there is not an X left in here, you will earn full credit. Now, I will clean it up because most people like to do that, but I will clean it up. Sine of 2 pi, so I'm just picturing my sine curve, goes out to 0, so 0 times all of that is 0, so that's easy. The cosine of pi, so now I'm picturing my cosine curve. Cosine of pi is negative 1. Sine of pi, so now I'm going to picture my sine curve, is 0. But now e to the 0 is 1, so I have 1 times negative 1, so I would say this final answer is just negative 1. But again, you could have left it in that huge form for full credit. Part B, let k equal this function, find k prime. So again, it's just a great question. They're just testing your derivative knowledge. Read it out loud. H of f of x. The second I said that word of, I've got a simple chain rule. So k prime of x equals chain. Derivative of the outside, keep the inside, times the derivative of the inside. Easy peasy. Plug in that pi, and we've got our answer. Now, you may have to clean this one up a bit further because it's still in function notation. So I want to be clear that this is different than the previous one on the cleanup because of the function notation. So now I need f of pi. So I have to go back to what function f was. And f was, let's see, f of pi would then equal the cosine of 2 pi plus e to the sine of pi. So again, I'm going to picture my cosine graph. The cosine of 2 pi would be 1 plus e to the sine of pi. So picture that sine curve. The sine of pi is 0. E to the 0, though, remember, is 1. Anybody to the 0. So I would say I get a f of pi is equal to 2. So now I have h prime of 2 times f prime of pi. Now if you cleaned up your part A, that was f prime of pi, we just said that was equal to negative 1. So if you didn't clean it up in part A, you had to clean it up in part B. And now I need h prime of 2. So I'm going to go to the graph of h. H prime would be to look at the slope. So since this is a line, everybody on here has the same slope. So my slope is rise over run. I'm going down 1, so negative 1, and running 3. So that slope would be a negative 1/3. So when I multiply those together, I would get a positive 1/3. Part C, let m equal this function, find m prime. So again, this is just a great question testing derivative rules, and I can totally see them going through something like this to be really nice to you on this exam. Find m prime. So if I read it out loud, it says g of, so there's my chain, times, there's my product, h of x. So there's my chain again. Okay, but I'm going to start with a product. So m prime of x is equal to leave 1 times the derivative of the other, so h prime of x, plus, leave the second one, times the derivative of the first. So g prime of negative 2x, and its chain, times the derivative of the inside, which is negative 2. I did use the chain over here. It's just times 1, so I didn't really need to write it. All right, so now I just have to carefully plug in 2, which could be a little fun. So I'm going to get g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. Okay, so g of negative 4 would get me that 5. H prime of 2, which I think we found in the previous one as a slope of negative 1/3, plus h of 2, so I need to figure out that value, times g prime of 4, which is easy because that's right here, negative 1 times negative 2. So now I just need to figure out h of 2. And actually, since we know the slope, that point to get is very easy as well, because each of these goes down negative 1/3. So that went down negative 1/3, that went down another negative 1/3, that went down another negative 1/3. So if I went down negative 1/3 twice, h of 2 would be equal to negative 2/3. And lastly here, I just need to figure out what each of these are. So this times this, multiply the tops over the bottoms, that's going to be negative 5/3. Multiply these tops, that becomes positive 2 times negative 2/3, becomes a negative 4/3. So I get a total of negative 9/3, which is equal to negative 3. Part D, is there a number in the closed interval such that g prime is equal to negative 4? So again, anytime they're asking for a derivative, okay, they're implying one of these theorems, either IVT or MVT. And because they said slope, again, think back to your 8th grade slope. Slope is equal to m. M stands for the MVT. Okay, so the first thing I'm going to do is I'm going to check two things. In order for the MVT to apply, the function must be differentiable. If it's differentiable, it also applies continuous. Okay, now I know g is differentiable because they gave me g and they gave me g prime. So now I'm going to apply the mean value theorem. Normally we say it's just the average rate of change equals the instantaneous rate of change. Normally we use f's. In this case, because they want g, we're going to use g's. So g of negative 3 minus g of negative 5 all over negative 3 minus negative 5. G of negative 3 would be 4 minus g of negative, oh shucks, I think I just picked the wrong one. Let me go back. G of negative 3 would be 2 minus g of negative 5, which would be 10, all over negative 3 minus a negative makes a plus. So I'm going to get a negative 8 over a 2, which does reduce to negative 4. So my first answer to the question, is there ever a number c? Yes. Since, and we're talking about function g of x is continuous, and I'm going to abbreviate there, on the closed. Remember those c words, continuous on the closed. And differentiable on the open. I'll be right there, buddy, okay? And g prime of c equals negative 4 by the mean value theorem. So I would definitely expect to see this on our exam in the upcoming week, the MVT and the IVT. Those are big theorems that we talk about in calculus. So keep this in a handy spot so you can refer back to it since it is open notebook. So I just want to stress again, if you totally botched this question, and that's okay, we need to go back and redo it. This is your time to get this practice in.